for now. More questions right now if you have them. I love the ones you guys have been asking. They're fantastic. Okay. Go, Deanne.
Unrelated. There's medication for syphilis.
Oh, is there medication for Congress? Well, there's elections. I guess there's elections, but we just elect more of them in. That's unfortunate medication.
You can medicate them.
Big takeaway, and this is on that sheet. If you guys have this sheet, all these big ideas are on there. Okay, so here we go. Big p-values. Big. Large. Nothing unusual happened. That's the snapping the fingers in the air going, darn it, we'll try again. We'll try again. In other words, whatever effect you're studying had no effect. Darn. I have a VCR in my office and I watch 3 minutes of a movie every day as I get changed for my commute, and I got Ghostbusters in right now. And it's the opening scene of Ghostbusters where Bill Murray is doing the ESP testing on the pretty blonde co-ed and the poor dude that's getting electroshock treatment for ESP. And he has his hypothesis that negative reinforcement negatively affects ESP, and every time the guy guesses wrong, he gets electrical shock. 1 point shooting the gun out. He's getting a large p-value. He's expecting something interesting to happen, but he's cheating the test, so he's getting a large p-value, so they have to go and catch ghosts instead. But the idea is, that's what big p-values mean. Big p-values, large p-values, mean that nothing unusual happened. So large p-values imply the two pieces of the conditional probability. So now think about this. In every one of those submax, max, and at-rest exercise, I had the blah, 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 given blah, blah, blah. What did you notice in the previous two where we had a large p-value? I'll back it back up. Oh, it's right there, never mind. We got our non-lowered heart rate data, assuming that caffeine has no lowering effect.
It's a large percentage of it.
Good, good. We got a large percent, large p-value. So these two pieces do what to each other? Contradict each other? In the English sense, yes. I like that. Okay. What Harrison just said, he said complement. If you use that in the English word not the mathematical one, because the mathematical one actually means the opposite. But if you need complement,
Would it be reinforced?
Reinforce, exactly, agree with, do not contradict. Lots of things can go in this slash, or in this space right here. But essentially, this piece and this piece agree with each other. There's no contradiction. They agree. They're harmonious. Complement in the English sense. I like that very much, thank you. Yes. That's a big p-value. You're expecting nothing to happen, and guess what? Nothing happened. So you're like, oh, okay, try again. Boom. This was The Fugitive. I've mentioned that movie like 5 times in this class. This is why Harrison Ford was running for his life. Because in the original data on whatever the cells they were studying, nothing unusual happened. But the people wanted a paper so they could get grant money, so they fudged the data to force the p-value to be unusual. Therefore getting a publication. And because nobody actually reads those papers, it got published. That's the inside joke about that movie on the scientific community. Yeah?
Yeah, that was something I was wondering. Like, because papers have to get sponsored, right? If you write an article.
Not necessarily. It can be peer-reviewed.
Okay, but they have to have something that like makes it stick out in order to get the funding to make
Generally, yes.
multiple copies.
Generally, yes.
Someone has to pay for it.
Not necessarily. I mean, it depends on what you're studying. I've seen wonderful papers written with absolutely no funding whatsoever. And I've seen crappy papers written with sponsored funding. The trick with sponsored funding, as Harrison's pointing out, very good point by the way, is that you've got to be careful who's funding the science. Yeah. Because if somebody is funding the science that wants to see a certain result, how can you remove the biased belief from that, right? But I've seen like 9-year-old, 10-year-old kids do touch therapy experiments. They're wonderful. They control for variables, no funding other than their parents buying cardboard and masks and stuff. So it's not so much sponsoring is a necessity, peer reviewing generally is a necessity, which means you write the paper and then it goes to a peer review, which is usually the New England Journal of Medicine, the AGA, or the AJA, excuse me, all kinds of organizations that will then publish your paper, but it has to go through a thorough screening process, and their job as the screeners is to pick any sources of bias out, or bad mathematics, and send it back and have you rewrite it or recollect data if they don't like it. Dan, you're going to say something, go ahead.
Well, that's just if it's published in an educational journal.
Of course.
You can publish in a magazine.
You can, but it still should be peer reviewed.
Right.
I mean, it should be. This is the problem with internet publications. You got to watch this. I'm going to have a data set for you guys later on. Did you know Twitter raises your GPA?
It does.
Twitter raises your GPA.
Crap, I
Well, then you better go get one because it raises GPA. And the problem with it is, it's an article, and we laugh because it's ridiculous, but it's published. But it's published on an online journal with no peer review process whatsoever. This is the problem with the internet. It's full of stuff.
Probably written by
And-
somebody who should have been doing their homework, but was
It's,
writing an
it's an
article.
interestingly written article, it's just the data collection is so horrific that it's meaningless. The math done on the data, spot on. The data itself, spot off. So that's the problem. I mean, you can put anything you want online. There's a joke, The Simpsons years ago, there was a scientific convention, and people are getting out of hand, out of hand, and out of hand, and scientist puts up his hand, pi is equal to 3! And I mentioned that because that got all the scientists' attention. I had a kid once that told me, well, pi is equal to 3? Like, no, pi is like a ratio of a circumference to it. It's 3.1415, blah, blah. He's like, this website. I'm like, what website? And he pulled it up. Pi equals 3. Now, what he failed to read was comma for all arguable purposes. So the admission is it's not equal to 3, but you can call it 3 if you want to get close enough to say build a cabin in the woods that's shaped like a circle. But the problem is that you can put anything you want online without any kind of... This is the criticism of Wikipedia. Although Wikipedia does a wonderful job of peer reviewing. If you've ever looked at one of the details pages on Wikipedia, I found errors on it and corrected them myself.
Yeah, people go in and say, hey,
It's like an infinite peer review process.
Yeah.
It's constantly being peer reviewed. So I have no problem with Wikipedia for that reason. But that's, you bring up a good point though, Harrison. Thank you for that. All right, so back to the big idea. Where are you if you get a big p-value? Within arguable Schuyler 2 standard deviations.